Give me that gooey, gooey, crispy, crunchy mouth.
That what you guys just heard was Down in the Delta. Star Spangled Banner, and Marches of the Armed Forces. If you guys want to see more 1v1 videos, you're more welcome to watch my videos of 1v1ing different people on BZ. I do it every weekend, or on every single summer break, or what type of break you guys want me to do it on. Just feel free to comment down below. I'm sorry if I do not talk much, because I usually focus. I just don't talk that much during live streams sometimes, guys. I apologize for that. And I will hope I'll be and you'll like I hopefully I'll be able to talk more on live streams, because I really talk much on any of those the other live streams, because I usually just want to focus. Or likely I'm gonna be talking to some of my friends because they're on the mic. So I'm gonna get started on my homework so you guys can see what I do. Trying to find the angle of measure D. So, if any of you guys are in 8th grade and you don't know anything about these angles, there's 4 types of angles that you guys need to know about. There's supplementary, there's complementary, there's vertical, and adjacent. Adjacent means that 2 angles are together. Complementary with a degree of 90, and vertical should be the same thing, I believe. So what you need to know here about some of these angles, they're going to try to trick you. But you also want to remember the equation for solving these. So look, if you just type in random of those applies that include, you think, like for example, if that one measures that, and you think it's 90, that doesn't work. And if you try to do it, let's say 48, which is not correct either, you need to be more smart about this. So, I suggest here you might want to get down a piece of paper and try to write down the equation to solve this angle D. Well, of course, if you're flipping on homework, you could just see here. You could just like get hint. You can search for hints, like for example, this here. But since sometimes they won't show up on our questions, you have to do the work on your own. If you're just gonna keep on going for hints and thinking that's gonna give you the answer, just make sure to write down a piece of paper. Get a piece of paper and start writing down and solving the equation and get this answer right. This is lock 13, which I'm almost done because I'm gonna screenshot pretty quickly in here as soon as I'm done with it. So
I'm gonna try to figure out this equation on my own. Let's see here. So, angle D. Do I switch? Let's see. I don't know if I split it or not. Well, that one split up. It's 48. No. Did not mean to do it. I apologize. So for angle D degrees. This is common. Oh, all right. You gotta be kidding me. I really just resetted my progress. I gotta do that again. Um, 49. So 49. So guys, I was just reading a message. Yes. Sorry, guys. I apologize. It just took me a little bit to try to figure out how to do it because I know the answer. I just forgot what it was. Apologize for that if that was getting you a little impatient. That's my sister. I apologize for that also.
In the high deserts of northern Arizona, there is a strange hole in the ground, known as the Beringer Crater. This crater was created when a rock from space collided with the Earth. The rock, called an asteroid, is estimated to have been about 30 meters across. That's a hunk of rock, ice, and metal about the size of a 9-story building. But as big as this asteroid was, the crater is a lot bigger. The width of the crater is about 40 times larger than the width of the asteroid, and it has well over 1,000 times the area if we compare them from above. And this striking difference leads us to our key question. Why do asteroids make such huge craters? Let's investigate the impact of an asteroid. Asteroids sometimes fall to Earth from space, and they fall quickly. This means that they have a lot of kinetic energy. Kinetic energy as it falls. What happens to the speed of a rock as it continues to fall? Cells are still, so they have no kinetic energy. Only this rock, rolling quickly down a hill, has kinetic energy. If we use a graph, we can track the rock's speed as it falls. What happens to the speed of a rock as it continues to fall? We can see how the rock gets faster and faster as it falls. We can also keep track of the rock's kinetic energy on a graph. What is happening to the kinetic energy of the rock as it falls? This graph shows that as the rock falls, it not only speeds up, it gains kinetic energy. Comparing the two graphs, we can see that as speed increases, so does energy. The faster an object moves, the more kinetic energy it has. Anything falling from space will have the same minimum speed, at least 11 kilometers per second. That's thousands of times faster than a car can drive. But even if they did travel at the same speed, not all asteroids would have the same amount of kinetic energy. That's because they have different amounts of mass. Mass is the amount of matter in an object, which we'll measure in kilograms. A small rock weighs about 1 kilogram, or 2.2 pounds. The asteroid that made the Beringer Crater had a mass of around 100 million kilograms. That's somewhere in between the mass of a skyscraper and the mass of a mountain. Most asteroids that fall toward the Earth from space are much less massive. The Earth actually gets hit by small asteroids fairly frequently, but their mass is too small to make a big impact. 3 asteroids are traveling at the same speed. Which has the most kinetic energy? The Earth from space are much less massive. The Earth actually gets hit by small asteroids fairly frequently, but their mass is too small to make a big impact. 3 asteroids are traveling at the same speed. Which has the most kinetic energy? The Earth from space are much less mass at the same speed. Not all asteroids would have the same amount of kinetic energy per second. That's thousands of times faster than a car can drive. But even if they did travel at the same speed, not all asteroids would have the same amount of kinetic energy. That's because they have different amounts of mass. Mass is the amount of matter in an object, which we'll measure in kilograms. A small rock weighs about 1 kilogram, or 2.2 pounds. The asteroid that made the Beringer crater had a mass of around 100 million kilograms. That's somewhere in between the mass of a skyscraper and the mass of a mountain. Most asteroids that fall toward the Earth from space are much less massive. The Earth actually gets hit by small asteroids fairly frequently, but their mass is too small to make a big impact. 3 asteroids are traveling at the same speed. Which has the most kinetic energy? Even though all 3 asteroids are traveling at the same speed, the more massive asteroid has the most kinetic energy. If we look at a graph of the energy of each asteroid,
So you guys just know I got that one wrong. Learn from what you have learned from your mistakes, cause that's what I do too. And that's when you're gonna continue. That's when you're gonna get it right the next time. So just remember that. Now let's continue on.
compared to its mass, we can see that as mass increases, so does kinetic energy. But remember, an object's kinetic energy is related to its mass and its speed. So, which has more kinetic energy? Energy of each asteroid compared to its mass, we can see that as mass increases, so does kinetic energy. But remember, an object's kinetic energy is related to its mass and its speed. So, which has more kinetic energy? Even though the skyscraper has way more mass, the stand has more kinetic energy. In fact, since it isn't moving, the skyscraper has no kinetic energy at all. But if something the size of a building were to fall to Earth from space, it would have an incredible amount of kinetic energy. And this is the key to our question. Why do asteroids make such huge craters? It has no kinetic energy at all. But if something the size of a building were to fall to Earth from space, it would have an incredible amount. To make a hole in the Earth as big as the Beringer crater takes a lot of energy. Asteroids move incredibly fast, so they have an incredible amount of kinetic energy just from their speed. But kinetic energy comes from both speed and mass. While asteroids vary in size, the one that created the Beringer crater was more massive than a large building. With so much speed and so much mass, the amount of energy released when this asteroid hit the Earth was greater than that of a nuclear explosion. Luckily, only a few asteroids of this size have hit the Earth in its history, and scientists don't think it's likely for another to hit anytime soon. Now that we've investigated, it's time to apply what you've learned.
Alright guys, that's the end of today's live stream. Hope you guys enjoyed, and I'll make more videos in the future. Hope you guys have enjoyed the live stream, and I'll see you guys in the next video soon. Bye.